without the work and dedication of the Scholarly Presentation Committee. The committee is composed of a diverse group of individuals that includes faculty, staff, administrators, and members from the Foundation and the Board of Trustees. I would like to thank the committee and the committee chair, David Stevenson, Communication Studies Professor, for their commitment to bringing topics of unique interest to the college and to the community. I hope you brought your scarves and mittens for tonight, because I'm really excited that we're going to journey back into the Ice Age, and it may be a little cold. But before we do that, I'd like to have David Stevenson make a few announcements. Thank you.
Good evening, everybody, and welcome to the beginning of our 20th year now of doing the scholarly presentation. So it's a great thing. When you get an opportunity, please look inside your program at some of our past scholars and some of the great presentations that we've had, and we have a few of them in the audience tonight. And how about if you are one of my past scholars, can you please stand up so we can acknowledge you? I think you're all going to enjoy Mary's show tonight. It's a fantastic presentation. She's put a lot of work into it, and I know that you'll all enjoy it, and it's very informative and very educational. I have a few instructions for the students that are all here tonight to get extra credit. And I hope you're here for more than just extra credit. But if you could remain in your seats after the presentation is done, because when Mary's done, then I'm going to bring up Audrey and Barry and Murray, and we have a plaque and flowers and an honorarium to present to her. I know that some of you have 7 o'clock classes, and if you do, if you could just kind of quietly scoot out to the side. But if everybody could stay in their seats, that would be fantastic. Thank you. I just have a couple of quick thank yous for the folks. Audrey is in tonight, and she's representing academic affairs. Dr. Barry Gribbons is representing the administration, and Murray Wood tonight is representing the foundation. Excuse me. I'd like to thank our committee. What a great committee we have. It continues to grow, and we continue to find great faculty members here who are very excited about sharing their scholarship with all of you. I'd also like to thank the PAC staff. They do such a fantastic job for us. Cougar News is here tonight, and they are going to be putting this up on YouTube in the next couple of days. So if you want to view it again or share it with your family and friends, and they will be doing that. I want to thank Graphics. I don't know if you saw our poster for tonight's presentation, but it is fantastic. They do our programs, and I'd like to thank them. And then all of the ECCS departments, did I get that right? ESES departments, they're responsible for all of those great displays that you saw tonight. So if you can, give them a great big round of applause. They worked really hard on that. Okay, I'd like to thank all the students, all the community members that are here. Just quickly, instructions, extra credit tickets are after the show, so please don't run out. And there is a reception tonight afterwards for COC personnel and, of course, Mary's entourage. So it's my great pleasure to present to you Professor Mary Bates. Thank you.
Good evening. Good evening. You know, when my 3 children were in grade school and I was 34, I decided to go back to college. And I came to COC and I started taking a geology class with Mr. Wutke. And I'm going, geology, rocks. Yeah. And so I thought, well, okay, field trip. All right. I went on this field trip, my jaw just dropped with the beauty, just the magnificence. I had never seen Mount Whitney before. I had never been to the Eastern Sierras. I had never been to Death Valley. And that field trip shifted the entire trajectory of my life. I went to school, I got my master's, I met new people, and to make a long story short, that, yes, that inspiration and the mentorship from COC and from Cal State Northridge has helped me be right where I am. Who knew? So I'm here to pay it forward and to probably inspire you to change your lives too. So my name is Mary. Let's go on a field trip. One thing that I learned the most about nature is how much it helped me make sense of my life. There are answers in nature and that helped me with my relationships, with my priorities, with viewing the world. What we think is chaos and devastation in nature, earthquakes are supposed to happen. If they weren't happening, we wouldn't see our mountains. We wouldn't have beautiful mountains. So the longer you look deep into nature and really be aware of what you're looking at, it will help you understand everything better. And that's not me, that's Albert Einstein saying that. One of my students sitting here among you tonight just took this photo last month when we were on a field trip to Morro Bay. And it's a beautiful picture at the beginning, but that's the neck of a volcano. This sunset is shining through some stratus clouds, which shows you that the air is very stable. Look at that rainbow. And the water is so still. Why is the water so still? It's because there is a barrier island of sand. Okay? So I love this picture. So thank you, Dylan, for taking this. Our planet is 4.6 billion years old, and there have been 5 ice ages within the last 2.5 billion. As you can see here, there are these 5 blips, these down part. Those are the colder periods. What we're concerned with tonight, what we're going to focus on tonight, is just the last 2.6 million years. And if you look at those 5 purple little diamonds there, those represent mass extinctions. In our planet's history, there have been 5 mass extinctions, where from 60 to 90% of all of the species of our planet wiped out, gone. Can you imagine that all of that extinction, all that chaos, whatever caused it, there are good reasons, our planet still goes on. Life goes on. It's different, but it still goes on. Of the last 2.6 million years, the Pleistocene started 2.6 million years ago and lasted until 11,700. And then ever since then, that's what we call the Holocene. Now, before we go on, I know there are those of you who might be thinking, were there dinosaurs then? No. These dinosaurs were already extinct 63 million years before the Pleistocene. So no dinosaurs tonight. Even though we might want to play in these dinosaur costumes, but this is not the Pleistocene. All right? We are still in the ice ages. Look at these glacial and interglacial cycles over the past 450,000 years. Everything below this line is a glacial period where it's much colder, and above it is an interglacial. And as you can see, that these glacial periods lasted about 10 times longer than the warm periods. And we're still in a warm period. We are in an interglacial. We really are still in the ice ages. And the reason we know that is because there are glaciers at Antarctica and at Greenland, and also some in our mountains. Now, human beings, Homo sapiens actually came onto the scene about 200,000 years ago during that period. So this is what Earth looked like, how much of it was covered with ice 22,000 years ago. If you look at this video, the North Pole is right in here. The thick white portions are the glacial ice sheets. The little grayer white, lighter white, that's permafrost. As you look at how these glacial and interglacial periods ebbed and flowed, notice the sea level changes over time in the Mediterranean, here, China and Korea. And you might think, gee, this glacial ice extended a lot farther south in North America than it did in Asia. Why would that happen? Some of you probably already know because you've been in my class. But this large landmass has less influence of moisture from the ocean, so there wasn't as much moisture over this drier continental climate than there was in North America. So North America's glaciers did move farther south. There have been times, even since the last glacial advance, when it was pretty chilly. It's called the Little Ice Age, and it was mostly in Europe and North America. It lasted for 570 so years. If you look at the image to the left, you see the River Thames in London, and children playing on the ice. People are ice skating. That's not the way it is now. The image on the right is Washington crossing the Delaware in 1776. Look at all the ice in the Delaware River. So it was much colder, but why? Well, there were many many volcanic eruptions. And when volcanoes erupt and you have huge ash clouds, it can dim the sky enough where the sun's light and the energy from it is not getting to the Earth's surface. So it's a dimming. It makes it a little bit colder. Also, there has been some unusually low sunspot activity during those times. So what are the natural causes of ice ages? Well, if you look at the image on the left, you know our planet revolves around the sun. There are some times when our revolution is circular. There are some times when that revolution is more eccentric, okay, and it's a little bit more oval. There have been times when our planet, our inclination is now 23.5 degrees, but sometimes it's been a little more, sometimes it's been a little less. And then as Earth is rotating on its axis, sometimes it wobbles. You felt that before. I know you've all felt a wobble before. And sometimes our North Star is currently above the North Pole, but there have been times when the star Vega has been above the North Pole. There have also been changes in solar activity, more solar flares, more sunspots. The sun has cycles too, and sometimes when there's a lot less solar activity, it does affect our planet. And our land masses have moved forever, and they still move. Plate tectonics, these land masses are always moving, but they're moving so slow, we don't notice it, but we get earthquakes, we get volcanoes erupting, and also a lot of volcanic activity, as I said before, a lot of ash. It does make a place a lot cooler. So there is nothing permanent in this world except change, and the Earth can certainly tell you that. We humans cannot alter or reverse any of those natural causes, of course not. But we do have an effect on our planet, and there are a lot of us, and we do severely damage the health of our land, our atmosphere, our oceans. We have the ability to do a lot of damage. There are a lot of people here, and we all want a lot of things. Take a look at the population. It took 123 years for our population to increase from 1 billion to 2 billion. But then it took only 72 years to add another 4 billion. We're really growing fast. Just a few months ago, our planet reached 7.4 billion people and is projected to be 9.5 by 2050. So please, in any choices you make, life choices, whatever you do, think and try to balance what's right according to your values, and especially try to make environmentally sustainable choices. That is our responsibility. The last time Earth was completely free of ice was more than 34 million years ago. And it'll happen again. It's happened in the past, it'll happen again. When all the glacial ice melts again, sea level will rise up more than 200 feet. Antarctica and Greenland, they're going to rebound. They're going to lift up a bit because all the weight of the ice is gone. It'll kind of pop up. And North America's coastline could look like this. Where's Florida? Where's Boston? Hey, New York City, where did it go? We have to adapt. Our planets, this has been happening on our planet many times. We haven't seen it in our relatively short time. New Orleans, gone. Here's our Central Valley. It's happened before, it will happen again. LA's might just look like this. This is the Bay of LA. This is the OC. Palos Verdes Peninsula is going to be Isla Palos Verdes. I love this one. Here's LAX. That'll be X-Lax. San Francisco may look like this. An archipelago is a cluster of islands. When sea level rises, San Francisco will be a cluster of islands. Okay, now let's go on a virtual field trip. Tonight we're going to see direct and indirect evidence of the ice ages on our planet. We're going to see it on our California's coast, our desert, and our mountains, and even the fossils that you can just go into LA and La Brea tar pits and take a look at them. Or hopefully you've taken a look at some out on in the lobby this evening. So we're going to look at these locations this evening. In fact, in your papers, I can't think of the word, the program, yes, thank you. In the program, there's an insert with a little map. If you want to do map quizzes, some of you know, oh, Mary's map quizzes again. If you want to take a look at it, there's a list of all the places we're visiting tonight, and you can later on figure out where they are, put those little numbers next to them. On the left is our current coastline. On the right is the coastline that was exposed during the Pleistocene. the sea level was nearly 400 feet lower. So this greenish yellow area is how far out the beach was. The coastline was a lot farther out. The Sierras were covered with ice. The deserts were full of lakes. This is the city of Santa Cruz. This is the city of San Francisco. San Francisco Bay, San Andreas, and Crystal Springs Reservoir. Notice it's in this deep line, this gash. San Francisco Airport. There's Bodega Bay, Tomales Bay, and Bolinas Lagoon, right in here. Notice that line. That's our San Andreas Fault. For those of you who like wine, there's Napa and there's Sonoma. Can't leave you out. Notice these islands in here. This is the California Delta region. It's a delta inside the state. We have islands inside our state, not at the coast. There's the Sacramento River coming from the north and the San Joaquin River coming from the south. They come up and they exit through San Francisco Bay. This is Mount Diablo. Native Americans thought that was the site of creation. As we curl around and look at this Hayward Fault, and here's the San Andreas Fault, we see this valley here that includes San Jose, Oakland. This is the my mind went blank. That's not the first time. So on the left, you see our current coastline at San Francisco. And take a look at this one. This arrow here is the San Francisco Bay Bridge. And this out here is the coastline 18,000 years ago. It was 34 miles, using this scale, 34 miles from this point out. Can you imagine? 34 miles out from where the bridge is now was the coast. These Farallon Islands, well, they were not islands then. They were just little hills on the land. So this animation shows you how sea level changed when it rose. San Francisco Bay is filling up with water. There was a lot of water, and then you see all these islands of the Delta region. Now let's look around Santa Barbara region. There's Santa Barbara here. There's Oxnard. Someone here lives in Oxnard. I know who you are. There's Santa Clarita, Thousand Oaks. This is the Santa Barbara Channel. You see the islands here, San Miguel Island, Santa Rosa, Santa Cruz, and Anacapa. Those Channel Islands were all one island when sea level was lower. It was called Santa Rosa Island. That was one island. Notice the extent of the edge of the island here and the edge of the coastline. There isn't that much difference in there. Now, there were Columbian mammoths that walked on the mainland in California, pretty large, 14 feet high. They were looking out over the water and saw some islands and, ooh, I smell food. Let's go for a swim. They started swimming over to the island, and it ended up that the species evolved to be much smaller, to be the pygmy mammoth, not much taller than I am. And these pygmy mammoths were only there on Santa Rosa Island. So as you can see here, and with sea level down, they only had to swim 4 miles. Those little guys just swimming around. They didn't only had to go 4 miles to get there. And then, these big guys were going, there isn't enough food. The little guys, I got it. I don't need much food. So the big guys die off, the little ones are doing fine. So in 1994, there is a 12,800-year-old complete pygmy mammoth found on Santa Rosa Island. And it is on display now at the Santa Barbara Museum of Natural History. You can go there anytime and take a look at it. Okay, marine terraces. Now there's land at the coast. And I showed you earlier there's a San Andreas Fault, plate boundary. The stuff is moving, land is being pushed up. Land is always being pushed up. But all that time, sea level is going up and sea level is going down. Sea level is going up, sea level is going down. Up and down, land is always being pushed up. You get a combination of those movements and you get these marine terraces, steps. These are visible on San Clemente Island. You see these steps here are marine terraces. You see them in Santa Cruz. The Oxnard Plain, Ventura. You see them everywhere if you know what to look for. They are on our coast. Desert lakes, my favorite. This is what was part of my master's thesis region. This is where my soul is. Now, during the ice ages, I had said that there was so much water that either the snow melted or more rain, and the lakes would fill up, and they'd fill up, and they'd overflow. They'd spill over, and they would fill up and spill over. Mono Lake spilled over into Lake Crowley area, over into Adobe Lake, spilled over into Owens Lake. Owens Lake spilled over through Fossil Falls, spilled into China Lake, into Searles Lake. It spilled into Panamint and into Death Valley, creating Lake Manly. So this yellow line here represents this same yellow line on this cross-section. Death Valley here, of course, is the deepest, the lowest elevation, and there were actually 3 river systems that emptied into Death Valley. One was from the Mojave River, and one was from the Amargosa River in Nevada, and then the ones in Eastern California. Now you have in that paper in your that I was telling you about on the other side of your little map, you have one of these images. And I did put some blanks. If you have a pencil, you can. If not, do it later. You'll probably remember. There are 4 lakes, and you can write them in. Number 1 was Lake Owens, and the blue area shows how far north it went, up into Independence. It overflowed, and then the second lake, Lake Searles, overflowed into Panamint Valley and became Lake Panamint, and it overflowed into Death Valley and became Lake Manly. I'm excited to show you this. I hope most of you have seen that augmented reality sandbox out there. If you haven't, then you must see it on your way out. I wanted to create a model to scale model, which I did, of this region, and I wanted to show you what it looked like for the lakes to spill over. So I wanted to show you that this image on your left, north is up. It's up there. And on this one, this image, replicates that. Now on the next slide, that one is going to be tipped on its side. And this is what that sandbox can do. Isn't that awesome, what that technology can do? So here's Lake Owens. It overflowed and went past Fossil Falls, filled up Lake Searles, and Lake Searles filled up, it was pretty deep, and spilled over into Lake Panamint. After that filled up, it spills over into Lake Manly. You'll see this little hill right there. You'll see it again later. There's a photo of it. It was an island in the lake at the time. But this really is pretty much to scale. So I'm really, I owe a lot of a debt to Mauricio and Justin, two Justins that created this. So kudos to them. Thank you. All right, along this Owens Lake, this dark gray area, it represents the highest lake level during the Pleistocene about 23,000 years ago. Now, you've all been to the beach, and I'm hoping that you have been to the beach with a lot of pebbles, a lot of larger pebbles. I know those who went to Montaña de Oro State Park with me over a few trips, you've heard the water flow over these pebble beaches. You could close your eyes and just hear the sound of these pebbles and washing over each other. It's quite loud. It's beautiful, actually, soothing. But imagine that same thing in the desert. How can that happen? Well, it did. At Owens Lake, at Swansea Bay, the wind patterns at the time caused most of the waves of this lake to wash up into Swansea Bay. And here, my esteemed field assistant and I went out, and you see the same waves from Lake Owens deposited these stratified layers, the same type of beach, 12 feet thick. We have samples out on the table. If you haven't seen it, you probably thought, what the heck is this rock here with all these pebbles? It came from here. The samples out there, the pebbles that are stuck together like that happened during the Pleistocene, during the Ice Age. Now, this is an image of one of those barrier beaches here. When you see these laminated flat pebbles like that, you know it was at a beach. There's a lot of energy, meaning the waves wash up and they swash back, pushes the rocks up, pushes the rocks back, and it flattens them and it laminates them nice and easily. And then lake level would rise, and it would be still water at this location, and when the water would rise, the fine-grained sediment would settle out, become lake bed sediment. And then lake water would go down again, and you get these alternating layers of low water, high water, low water, high water. And one of my mentors is sitting here in your presence also that taught me all of this, and if you transfer to CSUN and get her, she will tell you too. So along here, along the northern edge here, is where the edge of that beach was. Imagine, that far up the mountain, right up in here. And of course, I snapped a picture of Renee. She didn't know it. You can see how thick and deep this is. This level right in here represents just this part of the drawing. In fact, In this one level of the shoreline, right in here, there's a deathbed. Ooh, freshwater snails. Look, this is my ring for scale. This is how tiny those little shells were. Tiny little snails. 10,900 years old. So I took that photo and just enlarged it so you could see what it looks like. Okay. Now on the southern part of the lake, this edge of the shoreline is visible from this aerial photo I took when I was doing my thesis. Pretty distinctive. Also, the image on the left, you see Haywee Reservoir, and the edge here is also that same Pleistocene lake level. Haywee Reservoir is still there. It's kind of water's kind of low because of the drought, but it's still there. Here's Haywee again. As Haywee, that area that's filled into Haywee, it was spilling over. Well, there was a lot of rock. It actually cut a gap. So I put these little red lines here to show you where the level was, and then it cut a gap. The water is rushing through, came out here, would puddle here, over this volcanic rock. I put in Highway 395 so you can see that you pass by this every time you go to Mammoth, and you don't even know that that's what you're passing by. So Fossil Falls is right in here, and to show you again, repeat, there's Lake Owens, there's Lake Searles, and Fossil Falls is between them. Now this is all volcanic rock here. In fact, there were 3 main volcanic events. You can see the ages, it's in those little yellow circles. And each event like that, the water was still so abundant, it actually cut through. At first it blocked the water, the volcanic flow blocked the water, but then the water just flowed through and cut through every time. This graph shows these gray areas is how far that water spilled from Lake Owens. You could see that Lake Owens, that all the water from Lake Owens spilled into the Little Lake area, which is where these volcanics are, spilled into there that many times. Lake spilled over into Searles, spilled into Lake Panamint, this many, and then into Lake Manly twice. And the line represents the Lake Owens levels. So look at that volcanic rock over there. It's pretty rough, except that looks smooth. It's because water just polished it. This is a playground. I take my students there all the time. And yes, look at my cousin poking her little face up like a little gopher looking up. I love that picture. I love it. It's so fun. I take my students here every time I go past here. And then some of my best friends right there, playing around, goofing off. Goofing off. No one's supposed to goof off around me, right? I'm such a goof off. We're a kindred spirit. You could also take a nap in here, like my colleague did. As we're playing around, he's snoozing. Now, Searles Lake was so deep, you can see an image of the basin and how deep it is. It was so deep that it took so long to evaporate that water that there were a lot of salts, a lot of dissolved load. A lot of that water that was dissolved, the lake dries up, there you go. Every year, 1 weekend a year, the company that owns this industry, the salt mining, opens up the weekend for the public to come and break up the salt and take as much as they want home. And we have a lot on the table up there. Those beautiful pink halite crystals, I hope you saw those. There's Ryan and Kelly. And that's some of the samples they picked up. Okay. And this is the same salt you eat. This is another valley, Lake Panamint Valley. You see the white, but that's not salt. That's a mud flat. It's called a playa. So a gorgeous view looking south. Lake Panamint was shallower, and it overflowed more often. It overflowed and washed a lot of the salts into Death Valley. So there weren't many salts in this region. So what you have in the dried lake bed is more just the mud. It is really quite serene. If you ever have a chance to drive across Lake Panamint, pull over, get out, and walk onto that dry lake bed, it's very surreal. It's really quite peaceful. It's beautiful. It really is. Who would ever know that a mud lake bed was peaceful? You'd have to go out there. You just have to, I just want to take you out there and experience it for yourselves. Now here's Death Valley. This vintage map shows it pretty well. Telescope Peak is at 11,000 some feet, and it has snow in the winter. Beautiful. The deepest, not the deepest valley, but the lowest elevation in North America is in Death Valley. In fact, most of the time when you're driving through here, you are at sea level, but many times below. In fact, Badwater is 282 feet below sea level. And every one of my students who I've taken there, they park there, and I say, before we go out, look up at the mountain. And they look up at the mountain, and way up there, oh yeah, there's a sign. What does that sign say? It says sea level. That's really amazing. Sea level, way up there, 282 feet below. And then Dante's View, an incredible place to view. So this is actually salt in Death Valley. As I've said before, this valley was the final basin for 3 different drainage systems. The one from Owens Lake and Panamint. Then the Mojave River came flow from the San Gabriel and San Bernardino Mountains. San Bernardino Mountains mostly. And then the Amargosa River channel that came from Nevada. All 3 of them flowed into Death Valley, which is why there's so much salt there. One of my favorite places is Devil's Golf Course. You try to walk in through here. You drive, you take a little bumpy road. That's not far. You get out of the car and you're stepping over into the sand, and you got to step over and be careful. You step over here. No flip-flops. No bare feet. That's not going to work. It's very sharp, but it's so crazy. It is really fun. Some of my students here on a field trip, and many of you I know sitting here have been out here with me. Devil's Golf Course is crazy. It's fun. This salt was deposited there in the Pleistocene. So it is indirect evidence of the glacial, because glaciers weren't here, but it's because of all the water that flowed into these lakes and spilled over, carried the salts. So it is indirect evidence of the glaciers. My favorite, one of my favorites, is in Badwater. This is the lowest, as I mentioned before. You notice this white salt. There are people out there. People from all around the world come to Badwater to see the salt lake. They want to come and walk on this. So there are billions of footprints, and it's been well trodden. That's the path straight out there. And it looks pretty dry. Well, it is, kind of. But you know, if you just dig your hand in, maybe you're not supposed to, but if you dig your hand in anyway, and maybe a few inches, and you can get water. You can hit water and get your hands all wet. You get a little puddle of water. And a few years ago, it was about a year or so ago, it was like a freaky rainstorm, and it was so much fun because there's actually water out on the salt lake bed. It was very rare. So, of course, I had to take my students out. We're splashing in the water, and we get water all over us. It's kind of fun, beautiful, because you're walking on these salt crystals, bare feet, and you're walking on it and feeling it. It's really amazing. After you look at the salt, we drive up to Dante's View, and that's where that white salt bed was, just about an hour before when we were walking there. And to stand up there and look down, it's kind of a jaw-dropping experience to look at the expanse of the floor of the salt bed of Death Valley. Very contemplative, pretty cool. This is that little hill I was telling you about. Shoreline Butte, that was that little hill that was an island, and you can see that there are lake levels that are incised into that. All right, let's go to the mountains. This map shows glaciers in Yosemite. This is the Yosemite Glacier, Tenaya Glacier, Merced Glacier. This is the Tuolumne Ice Field. I put this red line and these arrows to show that this is kind of like a divide. And anything this side of the ice, the glaciers moved in that direction. This side of that divide, the glaciers moved north and northeast. Take a look at this animation. If you look at the bottom right, you can see this is when it was warmer, this is when it's colder, it's going to be warmer. This is Yosemite. Notice how the lake level at Mono Lake changes. The advance and the retreat, back and forth. Change is constant, isn't it? Okay, some landforms. Now, a glacial trough is a U-shaped valley. As glaciers plow through it, it's going to carve out this trough. It plucks rocks from the side and actually carves this glacial trough. You'll also see cirques. Cirques are these scoops, kind of a rounded bowl-like scoop that has been carved out by glaciers. They're up high. It's kind of like the birthplace of glaciers. And if you get several of these cirques, one here, one there, and one there around a hill, your mountain is going to become a horn, like the Matterhorn. So this is a drawing of a hill, a mountain, before glaciation, and then after many glacial periods, it keeps carving it back and eroding it away to where you have almost a pyramidal type of a peak, almost a concave peak. That's a horn. And then Paternoster Lakes are a series of lakes that are connected with rivers. Why is it called Paternoster? Paternoster is Latin for our Father and for the Lord's Prayer. And whoever named this, these chains of lakes, these lakes reminded them of rosary beads, of the beads on a rosary bead. So on a rosary or any prayer beads. So hence the name Paternoster Lakes. So let's show you some real pictures of them. Here is Yosemite, fully glaciated. You see Half Dome peeking its little head up out of there. The glacier is retreating. The glacier is gone, and you have a lake. The lake fills up. It becomes marshy, and it gets full of forest and trees, and this is our glacial trough of Yosemite Valley. Our classic California glacial trough. These are some cirques. I take students up Tioga Pass, and we always stop and take pictures. This is Mount Gibbs. Right here, that's actually a horn, but I put it here to show you the cirques. There's cirques on two sides. These are some pictures of horns from Tuolumne Meadows, right in there, and there are two right in here. And I take students here every summer as well. Mammoth Lakes is a series of Paternoster Lakes, and I take them down, and there's waterfalls, and we take pictures of the waterfall crashing next to us. Mineral King, these lakes are a series of Paternoster Lakes. This is in the Sequoia region. And this topographic map of Virginia lakes shows how many of these lakes were connected because the glaciers carved little steps and carved steps. And then when the glaciers are gone, those little steps are filled with water. Now, when glaciers are moving over some bedrock like this, it's going to abrade and polish and scrape the rock, and it's going to smooth it off, and you're going to have a smooth, real smooth surface. As it passes over, then it plucks off rock from the backside. So it creates this roche moutonné, French for sheep back. It's a very asymmetrical form, and you'll see this is an example of one where the glacier has scraped and polished and striated it, and you can see the glacier has gone from this way off to the left. Lembert Dome is a classic one in Tuolumne Meadows, and Pothole Dome, I take people here every summer. You can climb up in here, and people go, I can't do that. Yes, you can. My grandkids did. There they are. They're scrambling, but they got it up there, pushing his little butt up. He got it. They can do it. You can too. So glaciers polish and striate and scratch the surface. Devil's Postpile, the top of it in Mammoth, is a classic example. Now, when glaciers move, they actually pluck rock off of the side of the mountain. They pluck rock from the sides and from the bottom, and it's carrying all this rock like a conveyor belt. And the glacier's moving down, glacier keeps moving, keeps adding, keeps moving down, glacier keeps adding here, keeps moving down, glacier keeps adding, keeps moving down. And it's carrying all this rock. And as it gets to the end, it dumps all that rock. It dumps it all in these ridges, and those ridges are called moraines. There are moraines that are deposited along the sides, which are called lateral moraines. Ridges deposited at the terminus, or where it terminated, so it's a terminal moraine. And then as the glacier is receding, it deposits moraines, which would be the recessional moraine. McGee Creek is an excellent example of these lateral moraines, a beautiful aerial view. You can drive up in here also. You can see the lateral moraines along here very clearly. But how many of us fly over? What if you want to drive past? Can you see it? Yeah, you can. So here's Crowley Lake. 395 is back in here. You're heading north, and you notice this? That's this part that you're seeing, this lateral moraine. Now here's Convict Lake, a great aerial view as well. Lateral moraines along the side, terminal moraine along here, recessional moraines, recess, and there's a lake. In fact, Convict Lake is a moraine-dammed lake. And if you have been there, you recognize this beautifully, this U-shaped valley, and it's just still and beautiful. It's just stunning in all seasons. And so I took part of my family there, as you can see us happily posing. Now this is interesting. I said glaciers come and they go, that's true. This is a photo of two sets of moraines. The oldest one here is Sawmill Canyon. That glacier was there 120,000 years ago. Then there was a more recent one in Bloody Canyon. And this glacier was there 50,000 years ago. And how do you know? Well, look at these moraines. They've been cut off. It's almost like mud tracks. You're mud wumping with your truck and you drive off somewhere and then you come back and then you drive off another way. You've just cut off your prior your tire tracks. Same thing. Glacier came down here 120,000 years and then melted back. Interglacial. Okay, later on a glacial and comes down this way. So why did they go two different directions? Well, there are lots of time in between here, isn't there? Many thousand years in between. In the meantime, plate tectonics, that valley floor is kind of tipped with plate tectonics. In the tip. So then the next glacier moved off on the other side. So I take students here in the summer as well. This is Bloody Canyon, and this is Sawmill Canyon. It's not quite as easy to see from the road, but not just me, but many of my instructors, our instructors in the department, take students here as well. Now at Lake Tahoe, there are glacial features all over, especially on the eastern side. Emerald Bay is here, and that gorgeous bay is framed by lateral moraines. Fallen Leaf Lake is also framed by lateral moraines, and there's a terminal moraine right in there. Now, I said when the glaciers move a lot of rock, they can carry huge boulders. Now, these glaciers are a lot bigger than this building, much taller than this building ever was. And a rock the size of this stage, or half the size of the stage, no problem. It just carries along. It rides along. And when the ice melts, boom, it drops the rock. And these are called glacial erratics. Huge boulders. The only explanation for how they could get there is they must have been riding along on the top of a glacier. The image to your left, you can see a sequoia tree, the bark growing around one of these erratics right in here. Olmsted Point, you see many erratics. Now, there still are some glaciers in California. They are shrinking, sadly, but they are. Palisade Glacier. In fact, this image, I love this image. You could see the ice is pulling away from the edge of the mountain. We also have volcanoes on our state, part of the Cascade Range. Mount Shasta has Whitney Glacier nestled in the north side, and Mount Lassen also has some glaciers. They are shrinking, but they are there. Now, let's look at some fossils. It doesn't take long to drive down to LA, look at the tar pits, and see thousands of fossils that are at La Brea tar pits. In fact, one of our anthropology instructors took some cores of the tar around in the surrounding area, and she lent them to us to show you. So if you want to look at some tar cores, see what tar looks like in sand, and maybe some pieces of bone, who knows? We have them for you to see. So really thick, viscous tar, it looks like water to these poor unsuspecting predators. They're at the edge and they go, ooh, there's food. Look at that animal. I'm gonna go get some food. They're gonna go in the water, right? Yeah, well, they go in and then they're stuck. Oh, I can't get it. And then another animal goes, ooh, food. It comes in, it's stuck. So that's why there are so many preserved. They all went hungry. In fact, with the tar, when it was raining and there would be a puddle of water right on top and it would look like a lake. Oh, I'm thirsty. I'm going to go get some water and lap up the water, and then they get stuck. In fact, tar is such a superb preservative that it preserves birds. And you go, yeah, so what? Well, nothing else can preserve birds, fossils. They're such tiny, delicate fossils. They can preserve bird wings. They can preserve finest features of birds and bugs and beetles. They can preserve it where you couldn't in a lake mud or something like that. So this is why La Brea Tar Pits has the world's finest collection of bird and insect fossils. So this is a mural that is at the George C. Page Museum. The more water there's a lot more vegetation and a lot bigger animals. So this is the Saber-Tooth Cat. I'm sure you saw that big Smilodon out in the lobby. I call him Smiley. It's our California state fossil. There were more than 2,000 of them found in the tar pits. And look at, you think, oh, it's just a cat. These teeth are a little bit different. These saber teeth, these animals could open up their jaws like this, like 130 degrees. They'd have to open up their jaws like this for these saber teeth to get into their prey, into their necks. Okay? So you couldn't just do it with, it doesn't do it. It has to open up. It's pretty incredible what those little critters can do. So again, I'm very thankful for the support that our department had in order to purchase those models for our department. There's the dire wolf. 4,000 of these were stuck in the tar. 4,000. Most common remains. You have the American mastodon, similar to that woolly mammoth out there. The woolly mammoth with those tusks, those things just ate grass. What was the good for these tusks? Did they dig up the grass? No. These woolly mammoths live during the Pleistocene, snow, ice. They would take their tusks and push the snow away, push the ice away. And they go, there's my grass. And then they eat the grass. I know what you're thinking. It's legal now, isn't it? Ground sloth, up to 15. That was not meant to be part of my presentation. So these ground sloths can be up to 1,500 pounds. Imagine that. Okay, I'm not going to do it. All right. So this is the most common large herbivore, eating plants. Something big like that eats plants. How can you sustain something that huge as eating plants? I need a steak once in a while. Oh, I know. I'm not the best vegan, would I? I'm sorry, those of you who don't. Okay, so if you like to study past climates and you want to be out in the field, how do you learn about past climates? How do you do this? Well, you want to go out in the field, you could look at tree rings. Now, if there's a dead tree or an old log, you could look at the tree rings like this. But if you want to learn about trees that are still alive and you don't want to kill them, then you use a coring tool. And we have one on display this evening that is on loan from Cal State Northridge. Thank you, Emily. And so you screw that into the tree and turn it and turn it, turn it, and then pull it out, and there you get a core. The wider rings shows wetter years. The narrower rings are drier years. You could take cores of lake bed. Remember the deep lake bed? So you think, well, it's just mud. What does that show? Well, it shows the pollens that were alive, the trees that were alive. The pollen it blows off onto the surface of the lake, and it builds up water and it starts to sink down. It's full of pollens and seeds that tells you the vegetation that existed at the time that this particular level of the lake deposited that. Now, ice cores, not in California we don't do this, but this is how you can tell past climates. If you take ice cores from Antarctica and Greenland, you pull out this same core of ice. Look at all these little air bubbles. What you do is you get something like this. You get a bubble. You take a syringe. You're right into the bubble. You suck out the air, and somehow you can take this air, isolate it, and find out what percentage of that air is CO2, how much is methane, how much is oxygen, and other gases. So you can tell what the atmosphere was like at the time that this piece of ice froze. It's pretty fascinating. So as I've said before, our planet changes. It has gone through incredible changes. Sometimes the things that we think are the most devastating, the most disastrous, the most chaotic in our personal lives, or maybe out in the world, you look at nature and you go, what could be more chaotic than a lot of what our planet has already gone through? And it still survives. Comes back different, but it survives. Maybe it'll be better. But whether or not it's clear to you, no doubt the universe is unfolding as it should. Even if you don't like it, it might still be unfolding as it should. You have to give it a little time. But we still have to be responsible citizens. Don't just say, yeah, it changed. I don't care what I do with my life. I don't care. So what? The earth will be fine. Well, we still need to be responsible, for sure. So if you are interested in coming on a field trip with me or our department, I'm offering one January 20th and 22nd in the winter intersession, but you have to enroll in some winter classes. Now, if you want to enroll in classes, or maybe you don't want to enroll in classes, but you want to go on the trip, and I don't know, can I come if I don't enroll in the class? Well, email me, and let's talk it over. Thank you so much for joining me tonight. Hope you enjoyed it.
Great job, Paula. That was beautiful. Well done.
Thank you.
Yeah, that was awesome. Wasn't she fantastic? Let's give it up again for Mary. And I think we're all ready for a field trip, Mary. Here we go. Okay. I'd like to bring up on stage with me our three presenters tonight. Audrey Green from Academic Affairs, Dr. Barry Gribbins, and Murray Wood from the Foundation.
No, I do not want to follow that. Wow. I will be emailing you about your field trip in January.
I could do more.
That's fabulous. It's an honor to be here tonight to represent our Chancellor, Dr. Van Hook. She was sharing with me her opportunity to see your class and the passion that you have, the great enthusiasm and energy that you bring, and how that engages your students. And we all, I think, are blessed that we got a taste of it tonight. So thank you. I love the scholarly presentation and the celebration of our brilliant faculty. And again, I'm absolutely thrilled that you were selected and that you presented tonight. And you're such a wonderful ambassador, and you demonstrate the wonderful faculty and their ability to change all of our views of the world around us. And that's so important for all of for our society and for all of us to have this great experience and to shape our thinking. So thank you. Yeah. So Professor Bates, on behalf of our Chancellor, Dr. Van Hook, the Board of Trustees, the administration, and the college, please accept this recognition of your amazing work, and thank you again for sharing it with us tonight.
Thank you.
Okay, Mary, put the plaque away. Because these are prettier. They're not going to last as long, but they're pretty. Mary, on behalf of Academic Affairs, I want to thank you for sharing your passion, and I know how passionate you are and your commitment to your discipline. And I didn't know that you discovered it on a fluke, which I think is really awesome and shows that all of us can discover our passion at various times in our lives and pursue it and do what you've done. And I know your field trips are really important to you. Your students love them, and it's important to them learning the discipline. So thank you very much.
Thank you.
Why didn't I have a faculty member like you when I went to college? Terrific. My name's Murray Wood, and I represent the College of the Canyons Foundation. The foundation is the philanthropic arm of the college, and one of our longtime members of the foundation board was Judge Frank Kleeman. His widow is here with us. And Charlotte, will you stand and just wave? Frank was well-read, intellectually curious, and loved learning. For many years, Frank and Charlotte helped develop a support group for the library called the Library Associates. Frank was a learned man. He loved the college, and he understood how essential COC's faculty are to the transformational quality of the educational experience we offer here. Frank never missed one of the scholarly presentations. He found them stimulating and enlightening. At the conclusion of each presentation, Frank gleefully came up to the podium and he presented the honorarium on behalf of the foundation to the member of the faculty who delivered the lecture that evening. When Frank passed away last year, the foundation decided to dedicate our annual commitment in Frank's name. Therefore, it gives me great pleasure to present to Mary the Frank Kleeman Scholarly Presentation Award.
Thank you. Thank you.
And with all of that, we'd like to wish you a great evening. Thank you for coming.
Thank you.